Alright, last lesson of the unit. It's a little bit of a weird one. We're going to spend a whole bunch of time just to basically deal with how do we figure out what is the domain of a composite function, because it's not always obvious. Okay, before we do that, a little review. Hopefully you remember how to solve inequalities. If you remember that, what we did is we found the zero, so you think about it as what is x squared plus 9 equals 25, and then you said, okay, well, x squared would be 16, x is plus or minus 4. So we're going to put those on a number line and try to figure out what's going on in these areas, which one of these areas satisfies this inequality. Okay, so we would test -5. If we put -5 in here, what do you get? You get 25 plus 9. Is that less than 25? It is not, so that doesn't work. Then let's test 0. Is 0 plus 9 less than 25? Yes, that works. And then we would try 5, and you would see that doesn't work. So the solution, what is the solution here? It's anything between -4 and 4 that works, and we're including the values because you have less than or equal to. Okay? Let's try this one. Again, let's picture this equaling 0, just a factor. So x plus 3, x minus 2 equals 0. Okay? So we would have -3 and 2. And now what we want to do is we want to test. And this time we'll test a little different. These are a little easier if you think of it now as being back to greater than 0. So if we put in a -4 here, and put -4 here and -4 here, you would get negative times a negative and positive. Is positive greater than 0? Yes, it is. So that's going to be part of our solution. Then let's go and look at, let's put a 0 here. If we put 0 in here, this is going to be 0 plus 3, so positive, negative. So this is going to be a negative here. And then we put a positive 3 here, so that would be positive, positive. So what is our solution? What is greater than 0? Anywhere from -infinity to -3, round bracket, or 2 to infinity. Now you'll see why we need that very shortly. Let's get into today's lesson. Alright, graphing composite functions. So here are two functions, f of x, g of x. And let's quickly draw them. What do they look like? Well, if you remember, this would have been that graph. Okay, and then what would this graph be? This graph would be horizontal flip, and then what would that plus 3 do? If we put the plus 3 there, that would move it how? A little bit of a trick. Remember, this one we had to factor this out. And so this would be a graph that would look something like this. This would be 3, this would be 2, 1, and then over here we would have -1, 2. And those are the 3 points that we always know the graph. Okay? So if you forget how to do that, maybe do a little review of the first unit. The other way you could have done it is you could have graphed the line y equals -x plus 3. Okay, that's going to look something like this. And if you remember how to graph the square root of that, you would take it, where is it 0, where is it 1, and then do this. Same graph. Okay, if you're foggy about that, you probably need to do a little review. By the way, there will still probably be a final exam, so make sure you're keeping up. Okay, g of x, this is a parabola, and I can quickly determine that those are the x and y intercepts, and it looks something like this. Okay, what is the domain here? -infinity to 3, and the range is 0 to infinity. What is the domain here? -infinity to infinity, and the range is -1 to infinity. Now, when we were doing combining functions, we would just look at the domain and say it's the overlap. You're going to see here it's not that easy. Okay, we have to figure out a little bit about that. So let's take a look at the composite function f of g of x. And I've chosen some values here. You're going to see why in a second. Let's see what happens if we put negative 3 into g of x. Okay, just a reminder, g of x is x squared minus 1. So if I put a negative 3 in there, I get 8. Put a negative 2 in there, I get 3. Put a negative 1 in there, I get 0. Negative 1, 0, 3, 8. Now let's put those into the function f. If you remember what f is, it's 3 minus x. So we're going to put this value in here. So what is the root of 3 minus 8? Well, you can't do that. This doesn't exist. Okay? If I put a 3 into that equation, I get 0. If I put a 0 in, I get root 3. If I put a negative 1 in, I would get 3 minus negative 1. Take the square root, that's the square root of 4, so I get 2. And then these values would be the same. And so now you see why I picked those values. Really, the graph only exists right here. Why is that? Well, you can only take the square root of a positive value. And these values would give me a positive value when I stick it into there. Okay? So graphing this, so the points would be 3, 0, 0, root 3, negative 1, 2, etc. So I'm just taking these points. Okay, let's get rid of some of this. So here's the first point, here's the second point, here's the third point. Okay. Sorry, those are not the points. We actually have to take the x value, and then what is f of g of x? So at negative 2 it would be 0. Then at negative 1 you would have root 3. Root 3 is bigger than 1. And then you would have 0, 2. And move that down like that. So that's what that graph looks like. What's the domain? The domain is negative 2 to 2. What's the range? 0 to 2. Okay, now, wow, that's a bit of a strange question. If I would give that to you, how would you know how to do all of that? Okay, that's what we want to get at. First lesson here is that the domain is not that easy to figure out. We actually have to do the graph, have to understand what the new graph looks like. Okay, let's do another one like that just to kind of get a handle on this. Okay, so we have f of x, we have g of x. We're supposed to graph f of g of x. All right, to do that, I'm going to write the composite function. So I'm going to take f, g of x is x plus 3. And then I'm going to put that into the f function. So I have the square root of x plus 3. This is f of g of x. Okay, and that you should be able to draw. Right? Here's the root. If I want to move, if I have a plus 3 there, it's going to move 3 this way. Okay, so I'm going to have this point. Right, and then 1, 1 would become here. Okay, so this is negative 3, this is negative 2, 1. And then that one that was 4, 2, if I move it back 3, would become 1, 2. There is f of g of x. Okay, now let's do g of f of x. So I'm going to get g square root. And then I would get g of f of x is equal to the root of x plus 3. So that's the root, move it up 3. So you're going to have here, here, here. So this one is 1, 4, this one is 4, 5. Okay, that's G of F of X. Alright, now that's how we're going to do these questions. You're going to do the composite functions. Alright, and then you will know what the graphs look like because you know how most graphs look. And then the domain and range will be pretty easy to figure out. Okay, don't worry too much about the statement, but let's read it anyways. In this case, for the composite function f of g of x, that's this one. The function f is applied to the range of g. Okay, so in other words, what we get out of g, the domain was negative infinity to infinity. Okay, so in other words, we can put that into this, but it's limited because of the square root. Alright, that's what it says here. F is applied to the range, the domain is restricted to x is greater than 0. Okay? And that's, so f of g of x is defined when g of x is greater than 0, and that's when x is bigger than negative 3. You can see here the domain is from negative 3 to infinity. Honestly, these statements, to me, are confusing. I'm not going to use them when I do this. I'm going to show you a little bit of a shortcut. Okay, so the domain is from 0 to infinity here. Alright, here's what I would do. Okay, got this in general. This is what I want you to think about. In general, to determine the domain of a composition of functions, write out the explicit function. Okay, this is what we learned yesterday, or the previous lesson, whenever you happen to do that. Write it out. F of g of x. You're going to get some kind of an equation. You should know what it looks like. You'll know this. Alright, and you know, if it turns out to be a parabola, you know what a parabola is. If you know it's a radical, you know what to do with the domain and range. Okay? Find the domain of this composite function. Check. You know how to do this. Alright? Here's the little tricky part. You need to check to see if it's okay in the inside function. Okay? That's the key here. So let's go and try the question. So determining a composition function, we're supposed to do g of f of x and then state its domain. Okay, g of f of x we can do. Did this the other day. Let's combine it. So you're going to get g and f of x is x plus 3. Okay, now we're going to take g of 1 over x plus 3. So we're going to put this in for x here. So you get x squared minus 4x. And what are we going to put in for x? We're going to put this. 1 over x plus 3, 1 over x plus 3. Okay? Now, does it say to simplify? Determine an explicit equation. It does not say to simplify. I don't want to do anything with that. I'm going to leave it like that. Okay? Now, we're supposed to state the domain. Well, if you were looking at this function, you would say, hey, I recognize the square, that's a parabola. This has a domain of negative infinity to infinity. But now I should check the inner function. The inner function was, in this case, f of x. This is f of x. There's a restriction there, isn't there? X can't be negative 3. Okay, so that's as simple as it is. Write the composition, you can do that. State the domain of the function you recognize, and then look for extra restrictions. Okay, try another one. So I'm going to do f. What's g of x? G of x is x squared minus 4x. Okay, and then I'm going to put that into f of x. So that's 1 over, and then I have x minus 3. Oh, sorry, it's plus 3. And what is x? Putting this in there. X squared minus 4x. Okay, so I get 1 over x squared minus 4x plus 3. And you're looking at that and going, all right, what is this domain? Well, this domain, I see a quadratic. So I'm going to say the domain is negative infinity to infinity, but I also see some restrictions. All right, what is my restriction? Well, it's anywhere this would be equal to 0. So let's factor it. So then my domain also should say x cannot be 3 and 1. Okay? Hope that makes sense. Okay? We'll see there's a few more sort of little glitches. We'll try another one here. So g of f of x is the root of x. Let's put this into g. So you're going to get the root of x. That's going to be squared minus 4. The root of x squared is x minus 4. So g of f of x is x minus 4. What is this? This is a line. So what's the domain? Negative infinity to infinity. But you need to go and look at the inner function. What's the inner function? It's the root of x. Is there any restriction there? Yes. X has to be greater than or equal to 0. So now we're going to say, no, that's not the domain. The domain is actually from 0 to infinity. Okay? So again, go through the steps. Write the composition function. What's the domain? Look at the inner function for greater restrictions. Okay, we'll try one more. F, what is g of x? G of x is x squared minus 4. And now we're going to put that into the root. So you're going to get the root, and here is my x value, put it inside. Okay, so what is f of g of x? It's the root of x squared minus 4. Well, what's the domain of this? Well, the domain of this is anywhere this function is greater than or equal to 0. Well, now you remember why we did this at the beginning of the lesson. Okay, let's think of this as an equality. So x is plus or minus 2. So let's do a number line. Here's negative 2. Here's positive 2. Where is this greater than equal to 0? If I put a negative 3 in here, I get 9 minus 4. Yes, that's greater than. If I put a 0, 0 minus 4, is that greater than? No. And then here. So what is my domain? My domain is from negative infinity to negative 2. And then from 2 to infinity. Okay? And last step, we need to check, is that okay for the inner function? Well, that's a parabola, so all of those values are okay. So that's our domain. Okay. Almost done. Write a function as a composition of two functions. Okay, this is more of that kind of silliness. We're supposed to write what is f of x and what is g of x. So when we do f of g of x, it looks like this function here. Okay, here's what I would do every time. I would say f of x is what you see in the original function right here, and make g of x x. So then, how would you do f of g of x? Well, you would stick this x where x is, and it would become x. It's that simple. Okay? Let's try another one. Okay, what would you make f of x be? I would say make it x minus 2 squared. And what is g of x? X. Now I know they want you to do something more, fancy. They want f of x to be, why don't we say that's x squared, and why don't we say g of x is x minus 2. Then we put this in for there, and we get that. But whatever you want, doesn't matter. Make it easy. Okay, so f of x, what should we make it? I would say make it 3 plus x. What's g of x? I would say make it x. Alright, that is the end of that lesson. As I told you earlier, I won't ask you like this last question. I think those are kind of silly, but they could show up. Very likely they could show up maybe on the exam. I might put one on multiple choice just to keep you honest. But I'm more interested in if you know the rest of the lesson. Okay, since this is the end of the unit, after you have done the homework, alright, I want you to do, there's a practice test, there's a review. I also have my online review. It's a much more lengthy one. It's a much better one. I think you should always be doing those. There's one for every unit. Alright, and once you've done that, go and do the practice test and submit it. Submit. I was going to say submit to me, but that doesn't sound good. Submit the test to me. Okay, if you could do that, that would be great. Looks like we'll be doing most of the tests that way, so I do expect you to have every test submitted to me so that you can complete this course. Okay? Good luck with that. Let me know if you have questions.